Okay, this problem is very similar to one we've already done. Again, they gave me a capacitor. In this case, they gave me a resistor, and they're asking me to find the charge time. Again, keep in mind that the charge time, I'm just calling it T sub C, is 5 times tau. All right, just keep that in mind. When we come over here.
Wouldn't
and
you explain how they got those 5 to the negative 10s first?
Okay.
500 n to the f.
So 500 nanofarads is equal to, I'm going to move the decimal places over 2, all right? Well, nano is
9.
minus 9.
Minus 9 plus
adding
2 gives us
2.
that negative 7.
Right, okay. And over here, this is 10 to the third, and if I'm moving the decimal place here, I've got to add 2 to my 3, and I come up with 10 to the fifth, right?
So now,
Why do I do that? Only makes it simpler to work with, a whole lot simpler.
yeah. So now the formula for Towelie is if we take the C and the R, which they just gave us over here, and we're going to do a little scientific notation with this one. So first we had our 5 times 10 to the negative 7. Then we had our 3 times 10 to the fifth. Now, when we look at these, we can take our front numbers first. 5 times 3. What's 5 times 3? 15. Now let's look at our tens with our exponents. Whenever you're multiplying exponents, as long as you got the same hen, which in this case we have a 10 and a 10, so they are the same. We can just add them together. Negative 7 plus 5 gives us negative 2. So 15 times 10 to the negative 2. Now we're going to take that over and figure out our time.
And substitute it for tau. And we've got times 5. So 5 times 15 is 75, minus 2, boom, boom, 2 places to the left, and we're left with 0.75 seconds. Okay, so even with some pretty large resistances and some very small capacitances, we still only slowed it down by less than a second, right? All right, we're going to move to the next question. Be back.